Hey guys, welcome back. I'm trying to figure out the C one still, but I'm just looking, if I reflect it over the X, I land here, and I think they're trying to get me to this LJK. So let's take a look. This is the new D. It looks like this is the new E and this is the new F. It looks like it almost lines up here. It needs to go back to, but up to. So if I fixed this, it would map onto, so right here I'm going to say none. It doesn't map up on anyone as written, but if it was -2 plus 2, it would map on top of triangle LJK. Okay? Now let's take a look at 26. One class I think I had time, another one I didn't. So I think I did this by graphing. You can do this in math. It's just, I think, more work. So A is 7, 1. 7 positive 1. Okay. 7 positive 1. B is 2, 9. So 2. C is 3, negative 5. 3, negative 5. Okay, so there's my triangle, and I want to reflect it over the line y equal 3. So if I flip it over, since this is the x, this would be y equal 3. It's parallel to the x-axis. So instead of being 2 below, the new location of A would be 2 above. Instead of being 1, 2, 3, 4, 5, 6 above, I'm going to be 6 below. Right there. Instead of 2, 4, 6, 8 below, I'm going to be 2, 4, 6, 8 above. Okay, so this triangle was flipped over this line, and now it's sitting right there. It's been flipped over. Now, I can probably just read these off, and then it's pretty easy just using math to do transformation. So let's read these new coordinates after we flipped it. So A prime is 2, 4, 6, 7. 1, 2, 3, 4, 5. B, the new B is 2, negative 3. The new C is 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, now I'm going to translate. So that would be left 4, but do nothing to the y. So my final location, remember I don't have to call each prime each time I move it. I can do it multiple times, but I get the coordinate. Voila. Nice work. Okay, so we took some notes here in the first couple sections, and let's get to our question set. Okay, so here's our question set, and let's see what it says here. It says, look for the relationship if a figure has 90 degrees rotational symmetry. So I think we found out today this like little starburst thing would have 90-degree rotational symmetry. What other symmetries would it have? Well, notice it would be, it would also have any other, like 180. It would have 180s. It looks, we said today 180 degrees of rotational symmetry looks the same upside down and right side up, and this definitely does. You could also rotate it, I guess, to 70. and that would be the same. But I'm not sure that that's what that would mean. So I'm just going to leave it as 180. So Yumiko's work is shown below. What error did she make? Okay, so we're looking for a mistake. It says the figure is not symmetrical in any way. So this is a fancy way of making an S, isn't it? So when we think about this, if I fold it here, this line here, which see how this is a straight line, but this is a gap? So that's not going to work. But I think Yumiko's forgetting that this thing, if this is the top and this is the bottom, and then I flipped it upside down, it would look the same right side up and upside down. So this technically is symmetrical. It's just rotational symmetry, not reflectional or reflection symmetry. But it does have some amount of symmetry. So technically it has 2 degrees of rotational symmetry, or you could also say it is has 180 degrees of rotational symmetry. Sorry, Yumiko. All right, let's make some lines. So it says find all transformations that can be used to map on the figure. So if I folded it, that's a reflection. I don't think I can fold it here or there, nowhere else, just that one. So 1 line of symmetry. How many lines of symmetry does a regular 5-pointed star have? So I think we said if I put a 1 there, and I spin it, the 1 will line up here, and then it'll line up here, and line up here, and line up there, and then it'll line up with itself. So we're going to call that 5 rotational symmetries, but they don't want to know rotational, so I don't even know if we spoke about this. They want to know how many lines. So if I fold it here, right, that works. If I fold it here, that works. Here, that works. So I made the same number of lines. So this thing has the same amount of rotational symmetry as it does lines of symmetry. 5 lines of symmetry. And when I say symmetry, lines of symmetry, I mean reflection symmetry or reflectional symmetry. All right, what about this? Let's count the sides. 1, 2, 3, 4, 5, 6, 7, 8. So that's an octagon, which happens to have 8 sides. Describe its rotational symmetry. So if I put a 1 there, it would line up when I got a 2, and it would line up at this position, and this position, and this one, and this one, and this one, and this one, and back to itself. So I'm going to say it has 8, a degree of 8 for rotational symmetry. All right, it says when drawing in the style shown, the number 808 has horizontal, so if I fold it this way, it'll lay on top of itself, and vertical. So this one's horizontal and vertical, as well as 180 degrees symmetric. And I agree. This means it looks the same upside down as right side up. Okay, what are some other combinations of numbers with symmetry? List at least 3 other combinations and identify, oh, so this is cool. You can get creative. So, I'll be really boring, right? This number would be symmetrical here and here. And also the same 3 as above. Right? This one has vertical symmetry, horizontal symmetry, and 180 degrees rotational because it looks the same upside down and right side up. All right. Now it says list at least 3, so I don't want to take your creativity from you. List a few more there. Be creative. All right, let's look at some flags. So if we look at a flag, how would you decide which flags show reflection symmetry? So you make a line and fold it and see if it looks right. So this one's looking good here. This one's looking good here, right? Or here. And so I get 1 line of symmetry, 1 line of symmetry, 2 lines of symmetry, and this one's not looking good. I'm going to turn around my iPad. Does it look the same upside down as right side up? Yeah, so this last one looks the same, no lines of symmetry, but it looks the same upside down and right side up. So these are all reflectional. And this one's rotational. At 180 degrees, or we could say it has a degree of 2. So let's look at 27. How many do we have left? Oh, we're almost done. All right, I'm going to put this last one on another recording. So come on back for the last video.